In this video, I will discuss about Quine-McCluskey method. In short, it is also known as QM method. Quine-McCluskey method is used to simplify the Boolean expressions. K-map and Quine-McCluskey methods are used to simplify Boolean expressions. So in my previous videos, I have explained about K-map with few examples. There we have simplified the Boolean expressions using K-map. Similarly, the Quine-McCluskey method is also used to simplify the given Boolean expressions. It is difficult to simplify functions having more than 4 variables. In that case, Quine-McCluskey method is used. As if the number of variables is more than 4, then it is very difficult to simplify the function using K-map. In that case, we prefer using Quine-McCluskey method. Quine-McCluskey method is used to find minimum sum of product expressions for a given function, where function is given as sum of minterms. It is easy to determine prime implicants and essential prime implicants using Quine-McCluskey method. With example, I will explain the Quine-McCluskey method to find minimum sum of product expressions. With that, I will find prime implicants and essential prime implicants. Let the function is f of a, b, c, d is equal to, here minterms are given, that is 0, 1, 2, 5, 6, 7, 8, 9, 10 and 14. So in Quine-McCluskey method, the first step is, first I will represent the minterms in terms of binary. The highest number present in the minterm is 14. So to represent 14, minimum we need 4 bits. So we will consider 4 variables. First, let me represent these minterms in terms of binary values. That is, minterm 0, I will represent it as m0. So to represent m0, I will use 4 binary numbers, that is 0, 0, 0 and 0. Here the first 0 is with respect to A, this is B, this is C and this is D. And it is clear that this A indicates MSB and D indicates LSB. Similarly, I will represent the minterm 1 as 0, 0, 0, 1. Similarly, I will represent 2 as, that is minterm 2 as 0, 0, 1, 0. Similarly, 5 is represented as 0, 1, 0, 1. 6 is represented as 0, 1, 1, 0. 7 is represented as 0, 1, 1, 1. 8 is represented as 0, 1, 0, 0, 0. And 9 is represented as 1, 0, 0, 1. And 10 is represented as 1, 0, 1, 0. 14 is represented as 1, 1, 1, 0. So in Quine-McCluskey method, the step 1 is, so in Quine-McCluskey method, in first step, I will represent these numbers into different groups. I will make the groups depending on the number of ones present in a particular number. So first I will consider it as group 0. So in group 0, I will consider the numbers which are having only zeros. So here I have 0. So I can represent the minterm 0 as 0, 0, 0, 0. So this first 0 is with respect to variable A. This is B, this is C and this is D. Now I will represent the group 1. Now I will consider the binary numbers which are having only single 1. So here if we consider 1, so in 1 I have only single 1. So I can consider that in group 1. So that is minterm is 1. That is 0, 0, 0, 1. Similarly, if I consider 2, in 2 also there is single 1. Therefore, I will consider 2, that is 0, 0, 1, 0. Similarly, here in 5 we have number of ones are 2. Here it is 2. Here it is 3. And if we consider 8, in 8 there is single 1. So I will put 8 in group 1. That is 1, 0, 0, 0. So here in 9 we have 2 ones, here we have 2 ones, here we have 3 ones. So the group 1 is completed. So after each group I will put one horizontal line like this. So now I will consider group 2. Now in group 2 I will consider the numbers which are having 2 ones. So here in 5 we have 2 ones. So I will consider the min term 5. In binary it is represented as 0, 1, 0, 1. Similarly in 6 there are 2 ones. That is I will write it as 0, 1, 1, 0. So similarly in 7 we have 3 ones. Ignore it. In 9. So in 9 we have 2 ones. I will consider 9. That is 1, 0, 0, 1. So in 10 we have 2 ones. That is 1, 0, 1, 0. So in 14 there are 3 ones. So number of ones, that is group 2, is completed. I will put one more under horizontal line here. Now I will consider group 3. So in group 3 I will consider all the numbers in which number of ones are 3. So here the number 7, which consists of 3 ones. So I will consider 7, that is 0, 1, 1, 1. Then we have 14, that is 14, that is 1, 1, 1, 0. Thus we have considered all the minterms which are given in the functions. Those are divided into different groups. So this is the first step. I will call this as column 1. So now I will go to the next step. I will call it as step 2. I will write here only. So step 2 I will mention it as column 2. So in second step, I will compare the numbers present in one group to the numbers present in next group. That is, group 0 is compared with group 1, group 1 is compared with group 2, group 2 is compared with group 3, and so on. So now let me compare group 0 data with group 1 data. So here in group 0 we have 0, 0, 0, 0. In group 1, if I consider the first number, that is 0, 0, 0, 1, if I compare this 0 with 1, it is differ by only 1 bit. If it is differ by 1 bit, that data we supposed to represent in column 2. So here when I compare 0 with 1, it is differ by only 1 bit. So I will represent this as, so I will consider 0 and 1, that is min term 0 and min term 1, because I am comparing 0 with 1. So I supposed to write min term 0 comma min term 1. So now I will represent the data as, so 0 is here, here we have 0, here there is a 0, here there is 0, and 0, 0. Here we have 0, but here it is 1. So I will represent it as 0, first 0 is as it is, second 0 as it is, third 0 as it is. So it is differ by 1 bit in fourth bit. So the fourth bit, instead of writing either 0 or 1, I will write it as dash. That dash indicates either it may be 0 or it may be 1. So here 0 and 1 is differ by 1 bit. So now I will put the check mark for these two numbers. That is, for 0 I will put check mark, and for 1 I will put check mark. This check mark indicates these two numbers are differ by 1 bit, and those are written in column 2. Similarly, now I will compare 0 with 2. When I compare 0 with 2, again there is a differ by 1 bit. So I will consider 0, 2. So first bit is 0. I will write as it is. Second bit is 0. So there is a differ in third bit. So I will write it as Z dash, and again the fourth bit is 0. I will write as it is. So here 0 and 2 are compared. So already there is a check mark for 0. So no need to put one more check mark. So now we supposed to put the check mark for 2 like this. Similarly, compare 0 with 8. If I compare 0 with 8, it is differ in the first bit, that is MSB bit. And now I will compare 0 with 8. I will put check mark to 8. So it is differ in the MSB bit. So the first bit will be dash. Remaining bits will be written as it is, that is 0, 0, 0. Thus, we have compared each number of group 0 with all the numbers of group 1. So similarly, now I will compare each numbers present in group 1 with each number present in group 2, and I will represent only those numbers which are differ by 1 bit will be written in column 2. Let me compare 1 with 5. So if I compare 1 with 5, 1 is nothing but 0, 0, 0, 1, and 5 is nothing but 0, 1, 0, 1. So 1 and 5 is differ by 1 bit. The differ bit is nothing but this one. That is, here we have 1 and here it is 0. So I can represent these two as a group, that is 1 and 5. So I will represent it as, it is first number is 0. It is differ by second bit. I will write it as dash. Next two numbers are as it is, that is 0, 1. So this is 5. Now I will put check mark to 5, indicating that 1 and 5 are differ by single bit. So similarly, now I will compare 1 with, so here for easy understanding, we'll compare this 1 with the numbers which are having LSB as 1. Here LSB bit is 1. So here in 9 we have LSB bit is 1. So now I will compare 1 with 9. So here it is differ by 1 bit, that is differ by MSB bit. Here we have 0, 0, 0, 1. Here we have 1, 0, 0, 1. So I can consider 1 and 9 in which differ bit is MSB, that is dash 0, 0, 1. So now I will put check mark to 9. So now I will compare 2 with 5, 6, 9 and 10, and those are differ by single bit will be represented here. So here we have the second bit is 1. So I will compare 2 with all the numbers in which there is a second bit is 1. So if I compare 2 with 6, it is differ by 1 bit. The differ bit is third bit. I can represent it as 2 and 6, that is 2. I will put check mark to 6. So here it is 0, it is 0, and it is differ by this bit, that is, I will write the first 0 as it is dash. We have 1, 0. So now similarly I will compare 2 with 10. Here again it is differ by single bit, that is MSB. I will write it as 2 with 10. So here 0, 0, 1, 0. Here we have 1, 0, 1, 0. That is, I can write it as dash 0, 1, 0. I will put check mark to 10. Now I will compare 8 with 5, 6, 9 and 10. So here the MSB bit is 1. I will compare 8 with only those numbers which are having MSB bit as 1. Because other two numbers definitely it will be differ by more than 1 bit. So if I compare 8 and 9, we have 1, 0, 0, 0. In 9 we have 1, 0, 0, 1. It is differ in LSB bit. So I can write, I will choose 8 and 9. I will represent it as 1, 0, 0 dash. Similarly, if I compare 8 with 10, because 10 is also having MSB as 1, here it is 1, 0, 1, 0. So this 1 and here 0 is differ. So I can write 8 and 10 as 1, 0 dash 0. So already For 8 and 10 there is a check mark. We no need to put another check mark. So now group 1 group 2 comparison is completely over. Now we will compare group 2 with group 3. Before that, let me put a horizontal line here indicating separation. Now I will compare group 2 data with group 3 data. So now I will compare 5 with 7. So here MSB bit is 0, here it is 0, here we have 1, here we have 1, here it is 0 and here it is 1. So it is differ by this bit. So I can represent it as the min terms are 5 and 7, that is 0, 1 dash 1, 0, 1 dash 1. So already there is a check mark for 5. I will put check mark for 7. It indicates I have compared 5 with 7 and those are differ by single bit. Now compare 6 with 7. So here we have 0, 1, 1, 0. Here we have 0, 1, 1, 1. There is a differ by 1 bit, that is LSB bit. So I will consider 6 and 7, that is 0, 1, 1 dash, 0, 1, 1 dash. Similarly, I will compare 6 with 7. So in 6 we have 0, 1, 1, 0. In 14 we have 1, 1, 1, 0. It is differ in MSB bit. So I will consider 6 and 14. MSB bit is differ 1, 1, 0. So I will put check mark to 14. So now I will compare 9 with 7. It is differ more than 1 bit. I will ignore. 9 and 14 differ by more than 1 bit. I will ignore. Comparing 10 and 7, it is more than 1. I will ignore. Comparing 10 and 14, here we have 1, 0, 1, 0. Here we have 1, 1, 1, 0. It is differ in third bit. That is 1 is here and here we have 0. I will represent it as 10 and 14. That is 10 and min term 14. It is differ by third bit 1 dash 1 0. So thus group 2 group 3 comparison got over. So this is the final comparison. I'll put one horizontal line here. So now in step 3, again this process of comparison will be continued. Now we will consider column 2. In column 2 we will compare this group with this group and this group with this group, that is adjacent groups, as we have done in column 1. And only the numbers which are differ by 1 bit will be represented in step 3. I will call the step 3 as column 3. Now let me compare the numbers present in column 2. Now I will compare 0, 1 with all these numbers of second group. So here in 0, 1 we can see that in LSB there is a dash. So now we will compare this number with only those which are having dash in the LSB. So here we can find dash in the LSB. So if I compare this with this, there is a differ by only 1 bit, that is MSB bit. Here it is 0 and here it is 1. So while writing here, now I supposed to consider these two numbers and the min terms are, here the min term is 0, 1. Here the min term is 8 and 9. That together we supposed to write 8 and 9. So we are comparing these two. It is differ in MSB bit. So MSB bit will be dash. Next number is 0. Next bit is 0. And again in fourth bit there is dash as it is. It will be represented like this. So here we have compared 0, 1 with 8, 9. We supposed to put check mark for this and for this. So now there will be no more comparison with 0, 1 with other numbers. Now I will compare 0, 2 with all other numbers of next group. So in 0, 2 we have the third bit is, in 0, 2 we have third bit is dash. we'll compare this number only with those in which there is a third bit is dash. So here the third bit is dash. If I compare 0, 2 with 8, 10, there is a differ by 1 bit, that is MSB bit. Now let me represent 0, 2 and 8, 10 in next column. That is 0, 2, 8, 10, 0, 2, 8, 10. It is differ in MSB bit, that is dash. Next number is written as it is 0. Next there is a dash and next number is 0, that is dash 0 dash 0. So there is no more comparison with 0, 2. Now I will go to 0, 8. So in 0, 8 we can see that the MSB bit is dash. So here we have the MSB bit is dash. Now I will try to compare 0, 8 with 1, 9. So here by comparing these two I can say that it is differ in LSB bit. So I will represent 0, 8 and 1, 9. That is 0, 8, 1, 9. That is here we have dash is kept as it is. Next bit is 0 written as it is. Next bit is 0 and next bit is differ bit, that is dash. So now I will compare. Here we have dash, again one more dash is here. I will try to compare 0, 8 with 2, 10. So here first bit is dash, second bit is 0, it is same. Third bit is differ by 1 bit. So I will consider 0, 8, 2, 10. That is 0, 8, 2, 10. So there is a check mark for 0, 8. Now I will put check mark for 2, 10. So I will represent it as first bit is dash, next is 0, next is differ bit dash, next is 0. So thus we have compared all 3 bits with these all bits. Now we will compare the second group with third group. So now I will try to compare 1, 5 with the next group. Here in 1, 5 we have second bit is dash. So here there is no any, here we can find that second bit is dash. I will compare 1, 5 with 10, 14. So first bit is differ by 1 bit, that is dash, dash, and again there is a differ by 1 more bit. So we'll ignore this. We no need to consider because it is differ by 2 bit. So similarly now I will try to compare 1, 9. So here there is a MSB is dash, here there is a MSB is dash, but 1, 5, 1, 9 and 6, 14. It is differ by 3 bits. So we will ignore this. So similarly compare 2, 6 with 5, 7, differ more than 1 bit. 2, 6 with 6, 7, differ more than 1 bit. So now I'll compare 2, 6 with the 10, 14. So here we can see that we have dash, here we have dash. Next two numbers are 1, 0. Here next two numbers are 1, 0. Here MSB is 0, MSB is 1. So 2, 6, 10, 14. We can consider 2, 6, 10, 14. So here it is differ by MSB, that is dash, dash. Next two numbers are 1, 0. I'll put check mark for 2, 6 and 10, 14. So here we can see that in 2, 10 in MSB there is a dash. Here we have dash. We'll try to compare these two. So here it is 0, here it is 1, 1, 0, here it is 1, 0. Yes, 2, 10 and 6, 14. I can consider 2, 10, 6, 14. So MSB is dash. Next bit is differ by 1 bit. I will put it as dash. Next two numbers are 1, 0. So now I will consider 8, 9. So in 8, 9 the LSB is dash. Here the LSB is dash. If I compare 8, 9 with 6, 7, it is differ by 2 bit. We'll ignore it. So similarly, I will compare 8, 10, second bit is dash, here second bit is dash, but if I compare, it is differ by 2 bits, we'll ignore this. So all possible combinations got over. So now we supposed to stop this process. Group, I will put one horizontal line here because this we obtained by comparing first group with second group, and this is second group with third group. So now we supposed to look into all the columns, the min terms for which there is no check mark, those are the prime implicants. So here we can see that in column 1 all the min terms have got the check marks. We'll ignore this column 1. In column 2, here we can see that for 1 5 there is no check mark. So now I can say that this is one of the prime implicant. I will write it as pi, prime implicant. Here we have check marks. Here there is no check mark. So this is also prime implicant. That is 5 7 is prime implicant. Similarly 6 7 is also prime implicant. Similarly, so here 614, sorry 614 is already considered. So this is, we supposed to put check mark here. So now in this group, the min terms are 0 1 8 9. Here also we have the same min terms, that is 0 8 1 9. So instead of considering twice, we supposed to consider only once. So I will strike out this. So this will be the prime implicant, that is this combination is prime implicant. Similarly, we have 0 to 8 10. Here also 0 to 8 10, both are same. I will strike out this. I will consider this only, that is prime implicant. So this is prime implicant. Here we have 2 6 10 14. Here also we have same numbers, 2 6 10 14, that is same min terms, dash dash 1 0 dash dash 1 0. So we will consider only once, that is this is prime implicant. So now let me list the prime implicants. I will write here list of prime implicants. So here this is prime implicant 1 5. So the first number is with respect to A, B, C and D. So here it is represented as 0, means it is A bar. Here we have dash, we should ignore it. Then next bit is with respect to C, that is C bar. Next bit is 1, which is with respect to D. So it's supposed to be written as D because it is 1. Similarly, this 5 7 can be represented as A bar B D. A bar B D. This is done. I will write it as 1 comma 5. This as 5 comma 7. Next we have A bar B C, that is 6 and 7. A bar B C. So now in column 3 we have the first bit, that is 0 1 8 9. 0 1 8 9, that is dash 0 0 dash, means this is A B C, that is B bar C bar. Similarly, this is prime implicant 0 to 8 10, that is dash B bar D bar, B bar D bar. Similarly here 2 6 10 14, it is C D bar, that is 2 6 10 14, that is I can write it as C D bar. So these all are prime implicants. So now still we can identify the essential prime implicants, and still we can reduce few more prime implicants to reduce the Boolean expressions. So that can be done using the prime implicant chart. Now let me explain prime implicant chart and how to write the prime implicant chart and how to identify essential prime implicants from the prime implicant chart. So now let me write the prime implicant chart. This prime implicant chart consists of number of columns equal to the min terms given in the example. So here the min terms given are, those min terms we supposed to write here. The given min terms are 0, 1, 2, 5, 6, 7, 8, 9, 10 and 14. So all the min terms will be written column wise as I have written here, and on row wise we supposed to write the min terms, the prime implicants which we have listed. I will write these all prime implicants in the prime implicant chart. That is, first one is 1 5, that is A bar C bar D, 1 5, which is nothing but A bar C bar D. Second prime implicant is A bar BD, A bar BD, which is with respect to min term 5 and 7. Third one is A bar BC, A bar BC, that is with respect to 6 and 7. So next is we have B bar C bar, B bar C bar. Next we have B bar D bar, B bar D bar. Next we have C D bar, C D bar. Let me write the min term numbers, that is with respect to B bar C bar it is 0 1 8 9, 0 1 8 9. For B bar D bar it is 0 2 8 10, 0 2 8 10, and for C D bar we have 2 6 10 14, 2 6 10 14. So now I will put the cross mark wherever the prime implicant min terms are covered. So here A bar C bar D, the corresponding min terms are 1 and 5. So for 1 I will put cross mark and 5 I will put cross mark. Similarly with respect to second row we have 5 and 7. For 5 I will put cross mark, that is 7. Here we have 6 and 7, 6 and 7. Then we have 0 1 8 9, 0 1 8 9. We have 0 2 8 10, 0 2 8 and 10. Finally we have 2 6 10 14, 2 6 10 14. So now we supposed to identify the column which is having only one cross mark. So here in column number 14 we have only one cross mark. So I will select this one, put a circle like this. Similarly here we have, in this column we have only one cross mark. Select this. So similarly here we have two cross marks, here we have two, here we have two, here we have two. In rest all the columns we have two cross marks. So now the column which are having single cross mark, the corresponding row values are the essential prime implicants. Therefore here this cross mark belongs to the row 0 1 8 9, that is B bar C bar. So here B bar C bar is essential prime implicants. I will mark here. So this is essential prime implicant. Similarly this is essential prime implicant. So now essential prime implicants means these two we must consider in the. So now here we can see that this essential prime implicant is with respect to the min terms 0 1 8 9. So here 0 is covered, 1 is covered, 8 is covered and 9 is covered. Similarly with respect to this essential prime implicants we have 2 6 10 14. So with respect to this 2 is covered, 6 is covered, 10 is covered and 14 is covered. So here we can see that the min min term 5 and 7 is not yet covered. So now we supposed to consider the prime implicants which should cover this 5 as well as 7. So now we should consider another min term along with essential prime implicant such that it should cover the remaining two min terms. So if I consider 1 and 5, so 1 is already considered and 5, with this we can cover 5, but 7 is not covered. So we are supposed to consider such that it should cover the maximum number of min terms. So if I consider 5 and 7, it will cover both 5 and 7. So with a single min term or single prime implicant, I can cover 5 and 7. So I will choose this prime implicant which will cover 5 and 7. With this, we have considered all the min terms of the given function. There, so here a bar bd is prime implicant, but it is not essential prime implicant. Now therefore I can write the final expression, that is simplified Boolean expression, as f is equal to, first we'll write the essential prime implicants, that is cross mark, it belongs to this row, that is b bar c bar, plus we have another essential prime implicant, that is c d bar, and here we have another prime implicant, that is a bar b d. So this is the simplified Boolean expression, and this is solved using Quine-McCluskey method. Now I will compare this result with K-map results, and I will verify whether I will get the same result using K-map or not. Now I will try to simplify using K-map. Here the variables are AB, here it is CD. So 0, here we are supposed to write 1, at one cell 1, 2, we have 5, 6, 7, 8, 9, 10 and 14. Remaining cells we are supposed to write 0. So here we can get one quad. So value of this will be C D bar. So now I can do this group and this group as quad. So here the common factor between these two columns is C bar, and the common factor between this row and this row is B bar. Then we have one pair here. Its value is, the common factor here it is D. Here it is A bar B. A bar B. So therefore I can write F is equal to C D bar plus C bar B bar plus A bar B D. So here now we can compare. Here we have B bar C bar, here we have B bar C bar, here we have C D bar, here we have C D bar, and the another term is A bar B D, here we have A bar B D. Thus we got the same result with respect to K-map and Quine-McCluskey method. This is how we can use Quine-McCluskey method to simplify any Boolean expressions. Thank you for watching.